Okay, moving on to the next one. We're looking at the 5 note away perfect fourth. So it's a perfect fourth, not a perfect fifth, but the distance of a perfect fourth is 5 notes away. That always messes me up. I'll probably say it wrong multiple times as we go through this because it's easy to think that if it's 5 notes away, it should be a fifth. But no, it's a 5 note away perfect fourth. Okay, so this 4 represents that it's the fourth of our scale, and this 5 represents the distance from the root note in our scale, which in this case is A. Now, I also just want to note that I didn't do it last time, but I'm trying to think how I can work in also thinking as I do this, like that the distance between the Aeolian mode number 6, the beginning of mode number 6, is going to be the same as, or the distance between it and mode number 2, or Dorian, the distance from Aeolian to Dorian will always be a 5 note away perfect fourth. And I have a whole nother section that I've went over, a course that I talked about, like the shapes, and I talk about the idea that we should be, when we see these shapes, we see these particular patterns, right? And you should, you should be able to basically recognize the pattern, and I can name each of the notes. So whether I'm thinking about myself in Aeolian, Locrian, Ionian, Dorian, I'm using the same notes in the same pattern, and I can name the notes basically as the modal position instead of the relative position, right? So in other words, like this A is currently, of course, the first of the scale I'm working on, the Aeolian mode, the minor scale. But it's also from the perspective of a modal perspective, it's the Aeolian modal note, right? Or I could call it the modal note number 6 when I use my absolute numbering system, right? And if I looked at this C, then from the perspective of the minor, the A minor, that C is the third. But I can also see that C as it's the Ionian, right? It's the first note in the Ionian. So I can call it the start of the Ionian mode. I can call it basically the Ionian note within my shape. Why? And why is that useful? Because then this shape, no matter what mode I'm playing in, I can identify each note in the shape by its mode, right? Starting from that mode. So this C, I can identify it as the Ionian mode. That's where the Ionian mode starts. It's the Ionian note that would, if I started this whole same shape playing the scale from here, I would be playing in Ionian. And you can see that note is always in the same spot. I call this the house analogy. It's in this box. It's always in the top right of the box, if you look at it that way, right? You might say, what about here? Well, the tectonic plate shifted this move to the right. So here's the box from here to here. It's just that it got shifted, but it's always in the same spot, right? So if I'm able to see that, then I can start naming the intervals and say, well, what if I went from the Ionian note, right? Or what if I'm measuring from the A in this case, and I measure from the A note, which is the Aeolian note, to the D note, which is the Dorian. So I'm measuring from the start of the Aeolian to the start of the Dorian, which, again, I don't want to see what's the distance between A and D, because that's not movable. What is movable is that it is looking at the Aeolian note in the shape, whatever shape it is, whether I'm playing in Aeolian or minor scale or any other, the Aeolian to the Dorian will always be, no matter what, if I'm playing in the C major and related modes or to G major and related modes, doesn't matter. If I find the Aeolian note within that set of notes, and then I find the Dorian, there's going to be a distance of a 5-note away perfect fourth. I'm almost positive of that. I mean, that's right. And so I'm just thinking about this on the fly as I go here. So I haven't really rigorously thought this through, but I think that works. And I think that would be a useful way to see it. So I'm going to start maybe thinking like that. But okay. So then we're going from this A to this D, 5 notes away. Okay, so I could count out 1, 2, 3, 4, 5. Where's my orange? here. So boom. So on the same string like it was a piano, 1, 2, 3, 4, 5, boom, boom. So that's about as far as I can reach. Wait a sec, 1, 2, 3, 4, 5 out here. Sorry about that. It's like, what? That don't sound right. All right, and then, so then we're gonna go up one. So we're gonna, oh, what happened now? We're gonna go up to here. Okay, so I'm going above it. So it's a 5-note away, but, well, by the way, because this is the 4th, it's not included in my normal chord construction because it's an even number and we skip it. We go from the 1, the 3, the 5, and then to the 7, last note, and then we go around the horn to a 9. So the 5-note away perfect 4th could also be called a 5-note away perfect, or a 5-note away perfect 9th from a chord construction standpoint. All right, so if I go above it, I'm looking for a 5-note away perfect 4th or a 5-note away perfect 9th. I have to take the inverse distance because I'm going above it. So a distance of 5, 12 minus 5 is 7. So that means the inverse of the 5-note away perfect 4th is, of course, the 7-note away perfect 5th. So when I'm going above it, this is where it gets confusing. I'm looking for the 5-note away perfect 4th, but I have to look for a distance of 7, 12 minus 5, which is equivalent to the 7-note away. So don't get those two things confused, even though we're looking for the inverse distance and they're inverses of each other. And you have this 5 here and you have the 5 there, which is confusing. So it's going to be 5 distance right above it and then 6, 7. So if I count it from here, we're going to say 5 here and then 6, 7. So from top to bottom, that would be a 7-note away perfect 5th from the perspective of the D. Bottom to top would be a 5-note away perfect 4th from the perspective of the A. And therefore, if I go up one string, the 5-note away perfect 4th will always be 2 frets back unless I cross the fault line, which would happen if I was going from the G string, the B string up. So if I was on this A and then I went up to the D, now notice what happened. Here's my root. And because this tectonic plate, I visualize it, because when I go up, I visualize this plate as the one that's moving. It moved to the left, and that made a larger distance. It moved away from me as I'm standing here on A. So the general rule is that if I go up one string, the 5-note away perfect 4th will be 2 frets back unless I cross the fault line, which would happen on the B string, in which case if I go up one string and cross the fault line, the 5-note away perfect 4th will be 3 frets back. All right, let's go up two strings up and across the fault line. So I'm looking for a 5-note away perfect 4th, or a 5-note away perfect 9th, and I have to cross and I have to go above it. So inverse distance is 12 minus 5, which is 7. So a distance of 7. So a distance of 5 right above it, and then this tectonic plate shifted to the left, so I have to then move this way to go to another 5. I call that negative 5. And then I go down towards 0 this way. So negative 5, negative 4, negative 3, negative 2. What happened? This is, wait, no, that was 10. 5, 10. And then 9, 8, 7. There we go. All right, so if I'm up here, it's going to be negative 5. The tectonic plate shifted to the right. Negative 10 going this way brings me back towards 0, back up towards 0. Negative 10, negative 9, negative 8. Negative 7. So from here to here, so that D top to bottom would be a 7-note away perfect 5th. Bottom to top, therefore, would be a 5-note away perfect 4th. So that means that if I go up 2 strings and cross the fault line, the 5-note away perfect 4th will be 2 frets forward. But I wouldn't cross the fault line if I was starting above, like on the G above here. Then I could go up 2 strings and totally not even cross the fault line. So in that case, so normally, if I go up 2 strings, the 5-note away perfect 4th would be 1, 2, 3 frets forward, unless I cross the fault line. In which case, if I look from the perspective of this A, this tectonic plate shifted to the left, making it a lesser distance because it moved closer to me. So therefore, if I go up 2 strings and cross the fault line, the 5-note away perfect 4th will be 2 frets forward. Let's go up another string. Going up to here. So here's the long distance. 1, 2, 3, 4, 5. So it's 5 this way. So let's start there. So this is the one that's possibly just out of reach most of the time. So we don't use it maybe as often, but we're looking for a 5 note away perfect fourth. Distance of 12 minus 5 is going to be 7, distance of 7. So 5 here and then 10 here because this tectonic plate shifted to the left. So we're going to go a distance of 5, 10, and then 15 above it because there's no tectonic plate there. 15 minus 12 is going to be -3, and then I go more negative this way, -4, -5, -6, -7. Let's count it out actually on the guitar. So we're going to say -5, tectonic plate shifted this way, so I go diagonal, -10, -15, and then 15 minus 12 is going to be -3, -3, 4, 5, 6, 7, so open D. So if I went from the open D to the A, that would be a 7 note away perfect fifth, but from the bottom, A to D, therefore, is a 5 note away perfect fourth. Okay, so that means if I go up 3 strings, the 5 note away perfect fourth will be 1, 2, 3, 4, 5 frets back unless I cross the fault line, which would happen on the G string. If I started here, I wouldn't cross the fault line if I started above the G string. So I can't go here. So I have to look at the A like up here. So I have to go way up here. All right, and then let's just to get an idea of this. And then I go up 3 strings. So the general rule would be if I go up 3 strings, the 5 note away perfect fourth will be 1, 2, 3, 4 frets back unless I cross the fault line, which would happen on the bottom B and E string 2 out of 3 times that I could actually go up 3 strings and still have strings to go up 3 strings. So in which case, if I go up 3 strings and cross the fault line, due to this being my focal point and therefore the tectonic plate, this one being the moving one, going to the left, making the destination longer, the 5 note away perfect fourth, which could also be called the 5 note away perfect 9, will be 1, 2, 3, 4, 5 frets back. All right, repeat that 10 times. We're going to go to this one then, up 4 strings. Looking for the 5 note away perfect fourth, which could also be called the 5 note away perfect ninth. And we're going above it, so we have to take the inverse distance. 12 minus 5 is 7. Distance of 7. So going between the 2 strings, that's going to be a distance of 5. This tectonic plate is shifting to the left, so I have to go this way to get to 10, and then 15 right above it. Only 12 notes in the musical alphabet. 15 minus 12 is going to be -3, plus another 5 is going to be -8. So 8, and then we go this way back towards 7, back towards 0 to 7. Count it out on the actual guitar. So we're going to say this is going to be 5, and then tectonic plate shift this way, 10, 15. 15 minus 12 is -3, plus another 5 is going to be 8. 8 minus 1 is going to give us the 7, boom, boom. So top to bottom, from the D to the A, is going to be a 7 note away perfect fifth. But if I go from the A, bottom to top, therefore the inverse of 5 note away perfect fourth. That means that if I go up 4 strings, I will always cross the fault line because I can't go up 4 strings unless I start from a string that's below the fault line, because I don't have any room if I start from the G, and therefore, if I go up 4 strings, always crossing the fault line, the 5 note away perfect fourth will always be on the same fret, which could also, by the way, be called the 5 note away perfect 9 from a chordal construction standpoint. Let's go up to the top string and close this one out. 1, 2, 3, 4, 5. All right, so top string, if I'm on the bottom string, I'm gonna cheat, but it's not cheating. It's not cheating. I'm just doing what I know is easier. We can say that if I look, I can say that it's 5 notes this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that means it's going to be the same up top because those notes are the same, although different octaves. Okay, so, but let's count it out just to practice our counting. So it's going to be the long distance. So I'm looking for a 5 note away perfect fourth, which could also be called, so I have to look for the inverse distance, which is 12 minus 5 or 7. Going right above it is 5. This tectonic plate shifted to the left, so I have to go this way to get to the other 5, 15 or 10. And then going up 15, 15 minus 12 is going to be -3, plus another 5 is -8, plus another 5 is 13. 13 minus 12 is 1. I'm going to call it -1. plus 1, bringing us to 0 or 12 around the horn again. 12, 11, 10, 9, 8, 7. Whew. All right, let's try it from the bottom. Let's say this is 5, tectonic plate shifted this way to 10, and then 15. 15 minus 12 is going to be -3, plus another 5 is going to be 8, plus another 5 is going to be 13. 13 minus 12 is -1. Minus 1 brings us to 0 or 12, because that's the octave. 12, 11, 10, 9, 8, 7. There we are. So from this D to that A is going to be a 7-note away perfect fifth. From the A to the D, therefore, would be a 5-note away perfect fourth. That means that if I go up 5 strings, which I don't always do, it doesn't happen a whole lot, then, but I would always cross the fault line, and the 5-note away perfect fourth would be 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5 frets forward. Now, if I was on this string is the same as the top string, you will recall. So if I just repeat on the top string, and what if I went below it? Like you might ask, well, what if I go below this string? I don't have any strings, but I could go around the top of the guitar. But this string, if I do that conceptually, this string isn't below it. This string repeats. It repeats, and then we go below it. So looking from this distance below it is kind of the same as looking below this string, right? This string is repeated. And if I went below it, I wouldn't need to look for the inverse distance. I would say it's a 5-note away perfect fourth, a 5-note away perfect ninth. I only need to look for a distance of 5. There's a distance of what I call positive 5 right underneath it. So it would be right there. So it would just be from here to here. So that would be a 5-note away perfect fourth or a 5-note away perfect ninth. And therefore from bottom to top would be a 7-note away perfect fifth if I measured from the D. So if I'm going below it, one string below it, the general rule would be that it's going to be, it would be on the same fret unless I cross the fault line, which would happen on the G string. So if I was on this string, it would shift here, right? So if I go below it for one string, just for example purposes, I'm looking for the 5-note away perfect fourth or 5-note away perfect ninth, which would be, if I go down one fret, would be on the same fret unless I cross the fault line, which would only happen on the G string, in which case if I go down one string and cross the fault line, the 5-note away perfect fourth, which could also be called the 5-note away perfect ninth, will be one fret forward.